Have you ever wondered why that brand new, bright LED light you put up a few months ago looks a little dim and tired? Or worse, why it failed before its expected lifespan? We've all seen this happen. We invest in LED technology because it is energy efficient and long-lasting. We expect it to run for years. Still, when they fail, the culprit is usually an invisible enemy, heat, that sabotages them from the inside. Heat is an unavoidable byproduct of making light, and if you don't manage it, it gets trapped near the most sensitive part, the LED chip. That thermal buildup is the main cause of early dimming, color shifts, and outright failure. That turns your smart investment into a recurring expense. The good news, there is a solution: thermal management. It's not as hard as it sounds. It's a set of simple principles and practical steps anyone can learn and apply. By moving heat away from sensitive parts, you can greatly extend life, keep brightness, and ensure safety. The immediate key is to understand and control how heat flows. Think of it like a room's ventilation. The LED chip needs to breathe. It must send its heat into the surrounding air. If the path is blocked, the chip suffocates in its own heat, performance falls, and life gets shorter. So what is thermal management? In simple words, the art and science of controlling and moving heat. In LEDs, it means the whole system that pulls heat from the chip and dumps it into the air. That's the thermal path. Just like an engine will overheat without a radiator, an LED will degrade fast without proper cooling. Heat sinks pull heat from a tiny hot chip and spread it over a bigger area so convection can carry it away. The circuit board, thermal paste, and heatsink, each part plays a key role in making the heat travel fast and clean. Section 4. The heat alphabet, TA, TJ, and thermal resistance. When you read LED specs, you'll see TA, TJ, TC, and TJA. They are not scary, just simple ideas. TA, the ambient temperature, the air temperature around the fixture. Think of it as the room temperature. An AC office is 20 degrees C, a hot attic 40 degrees C. Those numbers are TA. TJ, the junction temperature, the operating temperature inside the LED chip. Keeping this under control is the most important thing. The main goal is to keep TJ below the manufacturer's max, otherwise dimming and early failure are certain. TC, the case temperature, the temp at the package outside or the heat sink point. You measure it with an IR thermometer. Engineers use TC as a real-world proxy for TJ. A high TC is a red flag that heat isn't moving well. TJA, junction to ambient thermal resistance. It tells how hard it is for heat to go from the junction to the air. Low TJA, so a wide multi-lane highway. High TJA, so a narrow country road. Less resistance means better flow. The whole system, from chip material to heatsink shape, must be engineered for low thermal resistance. Simple rule: the hotter it runs, the shorter the life. Just a 10 degrees C rise in TJ can cut life in half. The most common part, the heatsink, a passive heat exchanger, usually aluminum, that absorbs heat and dumps it to air. Aluminum is popular. Good thermal conductivity, lightweight, and low cost. In high-power designs, copper is a better conductor. It pulls heat faster, but it's heavier and costlier. Often the solution is hybrid, a small copper slug at the chip, then spread into a larger aluminum heatsink. Standard PCBs are poor conductors. That's why high-power LEDs sit on MCPCBs with metal bases to spread heat. Ceramic substrates are great conductors and insulators. And TIMs, thermal paste, pads, tape, fill micro gaps to make a smooth thermal path. Besides materials, the physical design and installation are critical. Even the best heatsink is useless if airflow is blocked. Fundamental principle: provide enough ventilation. If air gets trapped, it heats up and cooling stops. Don't cover LEDs in tightly sealed enclosures or insulation unless the fixture is specifically rated for that use. Fasten the heatsink securely. Keep the TIM a thin, even layer. Too much paste makes a barrier. Too little leaves air gaps. Drivers make heat too. Keep them separate and ventilated from the LED heatsink. A remote driver is better. A high-watt LED inside a small sealed can is a thermal disaster. The fix: lower wattage, an enclosed rated fixture, or proper ventilation. Thermal management matters for three things: LED lifespan, light quality, and fixture safety. At high temperature, the LED becomes less efficient. Lumen output drops and brightness falls faster. Overheat is a safety risk. Nearby wood, fabric, or insulation can catch fire. Cheap plastic housings can deform or melt. Proper thermal design is not just performance. It's a basic safety feature for homes and businesses. Ignoring thermal management is like driving a high-performance car and never changing the oil. You won't get the performance and failure is sure. A few easy steps. Cooler operation means longer life, steady performance, and a safer space. Let's put everything into 3 golden rules. Rule 1. Give heat a way out. Choose a visible, well-designed heatsink and don't block it. Rule 2. Let the air flow. Avoid tightly sealed boxes or spaces without circulation. Good ventilation is essential. Rule 3. Respect the datasheet. Check TJ Maxx, recommended TR, and suitable applications. Use high-temp rated fixtures in hot places. Quick checklist: heatsink sized for the watts, TIM used, driver separate and ventilated, clearance around the fixture for airflow. These steps will extend your LED's life, save money, and keep your spaces safely and beautifully lit. Did you get the thermal basics? Now the next step: choosing the right LED package. SMD COB CSP. High power real world uses pros and cons. And for quick selection tips, tap to watch the next video. See you there. Next up, LED packages and applications. SMD COB CSP. What's the difference? Where to use each package? Home, auto, or industrial? Stay tuned.